Yeah there. Today we are going to solve another LeetCode problem named minimum path sum. Medium level, and it goes like this. Given an MXN grid filled with non-negative numbers, find the path from top left to bottom right, which minimizes the sum of all numbers along its path. Note, you can only move either down or right at any point of time. There are some examples here which show that actually we don't need to return the exact path as a result of our code. Actually, we just need to return the sum of all numbers along the path. And we have some constraints. The most important one is that the grid is not empty because it has at least one row and column. Okay, so let's start to work on our problem. As you can understand, we are going to iterate through the rows and columns a lot. So let's calculate the last column index and last row index straight away. The last column index could be found as the amount of elements in the row, -1, and the last row index is calculated as the amount of rows in our grid, -1. Okay. Now imagine that we have an edge case. Actually, we have only one row in our grid. How could we calculate the path sum for the path from most left element to the most right element? So basically, we are going to just iterate through the row and make a sum of all the elements. So let's do this with one small detail. Let's save all the intermediate results. So in the end, we are going to have some kind of array of path sums of all the paths on how to reach each particular element in the grid. So let's name it something like current row paths. It's going to be an array of integers. We are going to fill it initially with zeros, and number of elements in it is going to be equal to the number of elements in our rows. Let's try to fill it. The first element, the path sum for the path of only one element would be, of course, equal to the value of the element itself. So no brainer, we are going to just copy paste it from the grid. As for the rest, let's use the while cycle and some kind of column index. So we are going to start from the column index number 1, and while it is less or equal to the last column index, we are going to increase it, of course, but also it's going to be used to fill the current row paths at this exact index. So each element in the first row could be accessed from the left, right? So the path sum for each element could be found as the value of the element which we could pick from the grid, plus the path sum of the elements tending to the left. So the value could be found as the grid of index 0 and column index. And the previous path sum could be found as the current row paths from column index -1. All right. Let's check actually if the last row index is greater than 0. Because if it is not, then actually we have this edge case. We have only one row in the grid, and we've already calculated the path sum for this case. So we could just return the last element from the current row paths. Okay. What if we have at least 2 rows? Well, let's try to calculate the next row paths using kind of the same code. So we are going to instantiate it with zeros. Also, let's create some kind of next row index, and for the second row it's going to be index 1. And let's try to fill this array, starting with the first element. The first element of the second row could be accessed only from the top, all right? So the path sum for it, of course, is going to be equal to the grid value, which is going to be equal to the grid next row index and 0 index for the column. And we are going to make a sum with the path sum of the element standing above, and it is the current row paths at index 0, right? As for the rest of the elements in this array, let's again use our while loop. So we're going to iterate through the column index, increasing it at each step. And let's try to fill the next row paths using this index. So again, we would have two components for the path sum. First, the grid value of the element itself. So we are going to just use the next row index and column index to access this element. And then we need to summarize it with the previous path sum. However, now we have two options because each element in the second row, except the first one, could be accessed either from the left or from the top. And as we are trying to find the minimum path sum, we are going to use the minimum of these two options. So the element on the left has the value of next row path, column index -1, and the element at the top, basically we are going to just use the current row paths, which we've already calculated, and we're going to use the column index to address the exact element. And basically that's it. If we have only two rows in our grid, then we could just return the last element from the next row path, and that's it. However, what are we going to do if there are much more rows? Basically, we need to do this code again and again and again. So let's create some kind of loop, while next row index is less or equal to the last row index. So we are going to execute this exact code to recalculate the next row paths. At each iteration, in the end, of course, we are going to increase the next row index by 1. And also now we need to save all the calculated values to the current row paths, replace the previous ones to be used at the next iteration. And basically that's it. Let's check for any compilation issues. Nothing here. And finally, let's submit our solution. Nice. So as you can see, the solution was executed in almost 0 milliseconds. So the execution time stands somewhere on the edge of the threshold, and that's why it beats 100% of other submissions. And that's it for today. If you'd like to see me solving other LeetCode problems, then put your request to the comment sections. See you next time. Cheers.